We're going to continue solving the 2012 AP Calc AB multiple choice part of the exam. We're now on the graphing calculator required portion. So let's dive right in. So this one, it says the graph of the function f is shown above. For which of the following values of x is f prime of x positive and increasing? Okay, so this is f. When f prime is positive, f increases. So we can already eliminate some of the answers. This f is decreasing. It cannot be A. At B, it neither increases nor decreases. So it cannot be B. It's right there at the turning point. How about D? That's decreasing. F is decreasing at D. So we eliminate over half the choices already. So when is f prime increasing? Well, when f prime is increasing, the second derivative is positive. When the second derivative is positive, that means f is concave up. So is it concave up at C? No, it's concave down. So our answer is E. Let f be a function that is continuous on the closed interval 2 to 4. So let's underline continuous, that's key. With f of 2 is 10 and f of 4 is 20. Which of the following is guaranteed by the intermediate value theorem? What does that theorem say? Well, let's say this is 2 and this is 4 and this is 10 and this is 20. Okay? Because f is continuous on the interval from 2 to 4, x is 2 to 4, and because at 2 it's 10, at 4 it's 20, by this theorem, when it's between 2 and 4, it has to cross all values between 10 and 20. So for example, 15. It has to cross that because it's continuous, okay? So what does this say? F of x equals 13 has at least one solution in the open interval 2 to 4. 13 is between 10 and 20. So it's like right here, somewhere like there, right? So I don't know if you can see that on camera actually, some dotted lines I drew. Because it's continuous, it has to eventually cross this point, this line, at least once. So this is the answer, okay? But we can go with the other choices already. F of 3, we can look at the other choices. F of 3 is 15. We don't know anything about function in between. We just know it's continuous. We don't know what value it is, so cross that out. F attains a max on the open interval 2 to 4. We don't know what happens in between. It could just be a straight line, like that. That's a continuous guy, and it also crosses, in this case, 13. We don't know if it attains a relative maximum min or whatever. F prime, okay, so immediately I can immediately eliminate these two because we just know it's continuous. We don't know if it's differentiable. So cross those two out. Okay. The graph of y is e to the tangent x minus 2 crosses the x-axis at one point in the interval 0 to 1. What is the slope of the graph at this point? Okay, so let me pull up my graphing calculator. So we graph this and we see where it crosses the x-axis. Okay, so this is what I graphed, so let's find the root. So it crosses at 0.606, around there. So I'm just gonna round a bit. Let me just write all the digits that my phone gives out. Okay, so this is where this guy crosses the x-axis. What is the slope of the graph at this point? So we need the slope of the tangent line at x is 0.606. Slope of the tangent line, that is derivative. So y prime is, you can, by the way, just plug this into your calculator. Like, you set this to be y and then n derive y with respect to x at this point. Something like that, if I remember correctly. I don't have my TI-84 anymore. But I can also do it by hand, because I can find a derivative. E to tangent x times secant squared. That is the derivative, okay? So we just evaluate at x is equal to 0.606112. I get about 2.9 6, somewhere there. And that looks like D, even with my rounding, okay? All right, so that's how we solve this one. Particle moves along the x-axis. The velocity of the particle at time t is given by v of t. Acceleration of the particle at time t is given by a of t. Which of the following gives the average velocity of the particle from time t is 0 to t is a? So I don't even know why they give acceleration, but to find the average velocity, that's the average value of the velocity function. So how do we find that from between t is 0 and t is 8? It's 1 over 8 minus 0, integral from 0 to 8 v of t dt. Do we have that? It looks like B. As simple as that. So I don't know why they gave the acceleration to find the t at this point. That's that. This one would be, you can interpret it as the distance traveled, total distance traveled from times 0 times 8, but then we divide by 8, so it's actually not that, actually. It'll be total distance traveled divided by 8. This one is just the average of the two values, not the average within the whole interval. This is the average acceleration, so that's not right either. So yeah, it's this one. The graph of f prime derivative of f is shown above. Which of the following statements must be true? Okay, so this is f prime. F has a relative min at x is negative 3. What happens at x is negative 3? The derivative goes from negative to positive. So there is a relative min at that point. Good. Graph of f has a point of inflection at x is negative 2. So since this is f prime, there should be a max or min, relative max or min at x is negative 2. Is that the case here? It's not. So we cross that out. By the way, why did I look for a max or min here? Well, when there's a max or min, that means the derivative of this guy, which is f double prime, changes sign from positive to negative or negative to positive. And that when the second derivative changes sign, that's when f has a point of inflection. All right, so that's why I was looking for that. The graph of f is concave down for x is between 0 and 4. How do I know if something is concave down? That is, well, when f prime decreases, f double prime is negative. When f double prime is negative, that means f is concave down. So hopefully that all made sense. Hopefully this sounds familiar also. So as I said, f prime should be decreasing for f to be concave down. So when is f prime decreasing? It's from 0 to 4. So this is good. So it's 1 and 3 only. All right. Water is pumped into a tank at a rate of R of t is that guy, gallons per minute, where t is the number of minutes since the pump was turned on. If the tank contained 800 gallons of water when the pump was turned on, how much water to the nearest gallon is in the tank after 20 minutes? We have a rate, we want a quantity after 20 minutes, integral is net change. So I think I made this mistake in some other video. I forgot to add this initial 800, so don't forget that. But it already has 800, so we can actually eliminate two of the choices. Because we're filling this tank, right? We're filling this tank with more water, so how can there be less water? Unless there's a leak, but it doesn't say that, okay? So, it has to be C, D, or E. We eliminate two choices right away. So, as I said, we want to integrate this rate in order to get the net change. So, it'll be 800 plus the integral from 0 to 20, because it's after 20 minutes, and this is measured in gallons per minute, of R of t dt. And this is a calculated question, so let me plug it into Wolfram Alpha and see what I get. So this guy I got is about 420, so it should be D then. Okay. That's that one. 82. F prime is this guy. Then F has a local max at x is equal to what? So let's just graph this and see where F prime changes from positive to negative. So let me graph that. So if I punched it in correctly, it looks like this. All right, so we want to find where f has a local max. So I just said f prime should go from positive to negative, which is over here. Let's find that root. That is x's 0.350. So choice C. As simple as that. The graph above gives the velocity in feet per second of a car for t is between 0 and 8, where t is the time in seconds, of the following, which is the best estimate of the distance traveled by the car from t is 0 until the car comes to a complete stop. Okay, so this is velocity, we want distance traveled, so we want to integrate. Okay, and it should be clear that we're going to integrate from 0 to 8 by the graph, and specifically it says from 0, so starting from 0, to a complete stop. That's when velocity is 0, which happens at t is 8. Okay, so how can we integrate this? Well, we are going to approximate the area under the curve. Okay, so we have to count the boxes probably. So each box is an area of 10, so that's convenient. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 16, 17, 18, 19, 20, let's say around 21 or 20. So it's probably D, 83D. Okay. For axes between minus 1.5 and 1.5, let f be a function with first derivative given by here. Which of the following are intervals on which the graph of f is concave down? So here is f prime. All right. When it talks about concavity of f, we want the second derivative. So I would just recommend you plug this guy into your calculator and then into another y. So this is like y1. y2 would be f double prime, which is n derive of y1 with respect to x, something like that, if I remember the command correctly. Okay, so I don't think my calculator and my phone has that option, so let me just differentiate this guy. Not that hard. E to the x to the fourth minus 2x squared plus 1 times 4x cubed minus 4x. Okay, that should be f double prime. So let me graph this one. Okay, so we want when f is concave down, which means we want f double prime to be less than 0. So when does that happen? If I graphed it correctly, then this is for x's between minus 1.5 to 1.5. So this is f double prime once again. F double prime is negative between negative 1.5 to 1. Okay, and then from 0 it looks like to 1 again. So it looks like it's choice D. Right, let me double check that is correct. Okay, that's what this key got. Okay, good. Let's move on. How are we doing on time? We're about almost 14 minutes in. Okay. The graph of f prime, the derivative of f, is shown above. The function f has a local max at x equal to what? This is like the other problem. This is f prime. F would have a local max if f prime goes from positive to negative. So that's at this point, which is C. Okay? As simple as that. Moving on. If f prime is greater than 0 for all real numbers x, an integral from 4 to 7 f of t dt is 0, which of the following could be a table of values for the function f. All right, so here, how can we solve this? I feel like I have done something similar to this before, so let me try to recall how to do this. Well, if f prime is greater than 0 for all real numbers x, that means f is increasing. Okay, so we must have some okay, so which of the following could be a table of values for the function f? Okay, so this is saying f is increasing. This is this point, okay? And then we have this point here. We have the integral from 4 to 7, f of t dt is 0. Okay, so the area under the curve from 4 to 7 is 0. So this means that, well, since f has to be increasing, that means so if this is from 4, this won't be drawn to scale, this is from 4 to 7, so that means since f has to be increasing and the net area has to be 0, sum of the function f has to be negative, and then at some point, this is not drawn to scale at all, let me move the 7 over here, okay? And then at some point 7, as I was saying, it'll become positive, so that the area would equal to 0. Okay? That's how we approach this problem. Okay, so one more time. F prime is greater than 0, that means f is increasing. It cannot be a constant. Why do I say it cannot be a constant? Well, if it's constantly 0, then this integral would work. If f is just always 0. But that cannot be the case because f has to be increasing because the derivative is always positive. Okay? So if f is always increasing, then that means part of f has to be negative, and then part of it has to be positive for the areas to cancel out. So let's see which one it could be within these choices. Okay? So this looks like it's all negative, besides, or 0 or negative, so it cannot be that. This is promising, some negative, one positive. This is negative, positive, but then decreases. Okay? So this cannot be it, because remember we said f prime is greater than 0 for all real x. That means f is always increasing. This is not always increasing. I also said it's always increasing, so it cannot be all 0. And this is increasing, but it's all positive, so that cannot be the case. So the answer is B. Hopefully that made sense. Okay. The graph of f double prime, the second derivative of f, is shown here from x is between -2 and 4, where all intervals on which the graph of f is concave down. F is concave down when f double prime is less than 0. So it's between -2 to 1. Didn't I just do this? I feel like I did something very similar just now. -2 to 1 and 1 to 3. I feel like I just did this. Am I going crazy right now? I don't know, whatever. But, okay, so it's when f double prime is negative, which is 2 to 1, 1, 2, 3. 87 is E. Okay? I feel like I just did this not long ago, or something very similar. Alright, anyway, I don't want to spend time to find it. Alright, a person whose height is 6 feet is walking away from the base of a street light along a straight path at a rate of 4 feet per second. So let's call this guy, okay, well, is walking, okay, let me just finish reading first. If the height of the street light is 15 feet, what is the rate at which the person's shadow is lengthening? Okay, this sounds like one of those similar triangle problems, which I don't like, but that's okay. It's not too bad, but what's happening here? Height of this guy is 15. Okay? Person is 6 foot. Right? So they are walking away from the base of a street light along a straight path at a rate of 4 feet per second. So let's call this guy x, okay? The distance between the light and the person, dx dt, that's the rate at which this distance is changing. It's changing at a rate of 4 feet per second. So dx dt is 4 actually, okay? So this is asking what is the rate at which the person's shadow is lengthening. So this is, if this guy is the shadow s, they're asking what ds dt is, okay? So how can we solve this problem? all right? So here I was saying we can do something with similar triangles maybe, all right? Because we can have a triangle here, and we can have a triangle from here, okay? So something like this and something like this, if that helps you visualize it even more. So when there's similar triangles, the lengths of the sides have equal ratios. Or something like that, right? Is it equal ratios? Yes, that should be correct. Okay. So let's take the heights first. Okay, so 15 divided by something, the other side is equal to the height of the person, 6 over the, okay, this would be 6 divided by s is equal to 15 over x plus s by the similar triangles, okay? So we have this. Now let us simplify. That would be 15 times s plus 6, sorry, is equal to 6 times x plus s. I don't like this s because it looks like my 5. But anyway, so we can simplify some more. So we can say this would be 6s. So 15 minus 6, that would be 9 times s is equal to 6x. Okay? Or we can even say s is equal to 2/3 x. Why did we want to do that? Well, we can now find ds dt. I'm going to continue down here. ds dt is 2/3 dx dt. And we know what dx dt is. It's 4, so it'll be 2/3 times 4. That is 8/3. So a little less than 9. So it will be this guy. Right? Okay, let's move on. Particle moves along a line so that its acceleration for t greater than or equal to 0 is given by this guy. If the particle's velocity at t equals 0 is 5, what is the velocity of the particle at t is equal to 3? Okay, so we could find the antiderivative and find the particular solution there, but there probably is a better way to do it because if you try to find the antiderivative by hand, I don't see a quick way to do it. And you can't use your calculator to find the antiderivative unless calculators are that fancy now and they're able to do it. But at least to my knowledge, with the calculators that I used in the past, you couldn't find the antiderivative. You can find a definite integral, but you can't find an indefinite integral with the calculator. Okay, so with that said, there is a better way to solve this, and that is simply using the fact that, whoops, my whole setup shifted, but we can use still the fact that velocity is the integral of acceleration, but if we take the definite integral from 0 to 3 of a of t dt, it is just v of 3 minus v of 0. Okay? We know what v of 0 is. Velocity at time of 0 is 5. So we can say v of 3 minus 5 is the integral from 0 to 3 a of t dt. So v of 3, velocity at time is 3, is just 5 plus integral from 0 to 3 a of t dt. And this you can plug into your calculator. As I just said, your calculator can find definite integrals. That's totally fine. So let me plug it into Wolfram Alpha and see what I get. So this guy I got to be around 6.71. So it should be 11.71 E. Let me double check that's correct. Good, okay. Let us finish up the last few problems. Hopefully I can do it within half an hour. Let's see. Let f be a function such that integral from 6 to 12, f of 2x dx is equal to 10, which the following must be true. So we probably need to do something about this 2x, right? It looks like it. So let's substitute u is 2x. du would be 2 dx. So we can rewrite the integral as, well, let's worry about our limits afterward. It'll be f of u, then it'll be dx is du over 2. So half du. And then we change the limits of integration when x is 6, u is 12. When x is 12, u is 24. Okay? Actually, what am I doing? Did I need to do that? Well, so this guy is also equal to 10. Okay? I just made a change of variables, a substitution. So this integral with this new variable u has the same value, 10. So if I multiply both sides by 2, then the integral from 12 to 24, f of u du is 20. So that looks like b. Okay? So I did need to do this in the end. Alright, I wasn't sure for a little bit. Let f be a polynomial function with values of f prime at selected values of x given in the table above, which the following must be true for x is greater than -2 but less than 6. Okay, this is f prime. The graph of f is concave up. How do we know that? I don't see how we would know that right away. Well, this one, there's a relative minimum somewhere here, it looks like. So it could have changed concavity. Well, f prime decreased then increased, so the concavity would have changed. Actually, it changed, so it's not always concave up. It would have, yeah, it's not always concave up, so we can eliminate that. By the way, this is a polynomial, so we know that f is continuous everywhere for all real numbers x. Okay, so that might be key also. The graph of f has at least 2 inflection points. Do we know that? Well, as I was saying earlier over here, the first derivative went from decreasing to increasing. Okay, and then over here it's still increasing, and then it looks like it decreased again. So the second derivative had changed signs twice, at least. So this seems to be true, so let's hold off on that. Is f increasing? Well, is the derivative always positive? It is at these points, but we don't know what happens in between the points. So it could be decreasing. It's not, might not be strictly increasing. So I'm leaning toward to not go with that, okay, because this must be true. So let's cross that out. F has no critical points. This is f prime. How would we know what f is? So I'm not leaning toward that either, but let's not cross it out yet. F has at least 2 relative extrema. Well, we don't know if the derivative changes sign or not. There's always positive, so we cross that one out. So I'm more confident in that it's b, and that's the answer, okay? There's at least 2 inflection points because, once again, it's a polynomial, so it should be continuous everywhere, right? For f, meaning f prime and f double prime are also continuous everywhere, since it's just a polynomial. And we see that it's decreasing and then it increased here. So there should be a relative min somewhere here, and somewhere there should be a relative max somewhere here. So there must be at least 2 points of inflection because the second derivative had changed signs at least twice. All right, let's finish up the last problem, I believe. Oh, it's a volume problem. Let R be the region in the first quadrant bounded by the graph y is x squared, and above by the graph of y square root x. R is the base of a solid whose cross sections perpendicular to the x-axis are squares. What is the volume of the solid? So let's sketch the region out real quick. First quadrant, y is x squared, looks something like this. Square root x looks something like this. Okay? So this is our region R over here, the shaded region that I'm going to very lightly shade. I don't know if you get, or you can kind of see it on camera. Cross sections perpendicular to x-axis are squares, so there's a square here, there's a square here, so on and so forth. How do we find the area of a square? That's the length of the side, and we square it. Not a pun. Okay? No pun intended there. So, what's the length of the side? That is just square root x minus x squared. That's the length of this side right there. Let me call that side s. S is equal to that. Okay? So, the volume would be integral of side squared dx from, what's this point and what is this point? Well, we know that this point is the origin, so 0. I can easily guess that this point would be x is 1. Because when x is 1, y is 1 here. When x is 1, y is also 1 there. So that's a good guess. If not, you can just set these equal to each other and solve for x. That also works. Or you can plug it into your calculator. So this is a calculator problem. This is a calculator section, okay? So, but since I already know, just by a very good guess and by sketching, I know it's from 0 to 1 side squared dx. This is the volume. So what is s? We found it over here. Integral from 0 to 1 square root x minus x squared, this whole guy squared, dx. And I would just plug this into your calculator now to solve for this integral. So let me do that plug it into Wolfram alpha. Give me a few seconds. It is square root x minus x squared, the whole thing squared. Okay, and I get that this is 0.129, something like that. Oh, yeah, sure say. Okay, and that is the graphing calculator required portion of this exam. Hopefully this was helpful for you. Please like this video if it was, and also please don't forget to subscribe to get notified for the next test that I'll do or next video that I'll post.